Hi everyone, and welcome to our video on finding derivatives of natural log functions that have some kind of interesting stuff going on inside of them. Okay, so if you're following my exact order, which I hope you are if you're in my class, if you're just a random person watching these, then thank you. But if you're following the exact order, I did this problem in the last video, number 3, and now it's erased. I'm going to do it again. Okay, we're going to do it a different way. So in the previous video, I just wanted to make sure our derivative rule for the natural log was instantly getting applied. However, there are some rules with logs from algebra and pre-calculus that can help us do these problems that have nastier stuff going on inside of the log. Okay, so I think I'll have enough room to put it down here. So we have, these are just algebra log rules. So one of them is if you have, and I'm just going to do natural log for instead of any other log, because that's our main natural log. So this is with base E. But if there's something inside of there, let's do capital A times capital B. So if we have ln of a product inside of this, so this is called the argument, this thing in the parentheses, what we can do is rewrite it so that it's two separate logs with an addition symbol in between. So ln of A plus ln of B. Let me go ahead and box that. That's one of the rules that can help us. Number 2, if those two are divided, so ln of A divided by B, well, it looks similar to above, but change it to minus. Okay, so ln of A minus ln of B. And then the third algebra rule that can really help us is if we have this A raised to a power, then we can move the power to the front like a coefficient. There we go. So P ln of A. So whatever that number, or even if it's a letter, you can put it out in the front. Okay, so these are our rules that can help us. So this is like a product to sum, quotient to difference, and then power to multiplication. Okay, so those can really help. So for instance, even this very first one, I'm just going to rewrite it right here, that we did from the previous video. If I use this multiplication rule, I do have 20 times x right here. So times, let's get that little dot, times x. So that means this is the same thing as ln of 20 plus ln of x. And then doing the derivative, dy dx, natural log of 20's derivative, well, that's just a number. This is a constant here. So that means its derivative is 0. And then ln of x's derivative, that's the most basic form. It is 1 over x from up in the table, which matches this answer. Okay, so the rules can be used on other problems as well. Number 2, though, let's just point this out. Number 2, we can't use any of these rules because inside the log was subtraction, not multiplication, not division. Okay, so this one we did have to just go through it using our definitions of the derivatives of natural logs. Okay, however, let's go back to number 3. So number 3 we did in a previous video and it got a little nasty. Let's see if we can use this rule to help us. Okay, so either way, number 3, we can rewrite. So that's how we started it the first way. But now we can use our algebraic power rule. Okay, so careful. So it's not a derivative power rule. So we're going to use this number 3 and say, let's just have this 1/2 move to the front and multiply with that 8. So let's multiply 8 and 1/2. So I'll have 4t ln of 3t minus 7. Okay, so now this is an easier problem to work with because there's no more power on the natural log. However, it's still a product rule. So we still have that and that getting multiplied as variable expressions. So that means it is a product rule problem still like the first one. However, it should be an easier product rule. Okay, so the 4 is just hanging out. And then I know my derivative, so I'm just going to write a side note. We know it is u prime v plus uv prime. So there's my side reference. And then I've got, this would be u. The derivative of u would be 1. Derivative of t is 1. And then we'll just write in the natural log of 3t minus 7. So that's the v part. Okay, so all of that in the purple is v. All of that in the blue is u. And then we do have plus, u is still t. And then v, we need its derivative. Okay, so it's a natural log function. We know we can just put 3t minus 7 down below and then do the derivative of what we just wrote in the numerator. So the derivative of 3t minus 7 is just 3. Okay, so that's it. So it's a lot easier. So again, if you watch that whole video of the last one, that required the chain rule inside. Okay, and then now we need to just simplify. Okay, so we get s prime of t would be 4, and then ln of 3t minus 7. And then this t right here and that 3 would multiply, so we would rewrite it as 3t over 3t minus 7. Like that. Okay, and that should be fine. But if they said, oh, get a common denominator, real quick. So this currently is under 1. So the 3t minus 7 needs to multiply both the top and bottom of that. 3t minus 7 and 3t minus 7. I'm squeeze that in. It's tough to read, sorry. But let's rewrite it now. So it's 3t minus 7 in parentheses. ln of 3t minus 7. And then plus 3t over 3t minus 7. Okay, so that's done. Okay, so again, the last video, we went all the way to the bottom of the page almost to get this whole derivative. Okay, so this one is a lot cleaner, took a lot less steps. Okay, so these rules can really help. Okay, so if you've got something really strange inside a natural log, it might be worth thinking about these rules first. Okay, so for instance, on number 4, let's rewrite it because we do have a quotient right here. So that division bar, let's use our algebra rule for logs. So we're going to rewrite it. So g of x equals, again, the 4 is just hanging out. It's just a constant. And then using our algebra rule, it's saying you should have ln of the absolute value of 3x plus 5. And then this division bar, we're going to say it should change to minus, and then we should have another ln of everything in the denominator. So 2x squared minus e to the negative 2x. Okay, so that was this division in the log to subtraction with separate logs rule. And then let's go through it and do our derivative. So it's ready to go now. We've got g prime of x is equal to, okay, so the 4 is just hanging out. And then we're doing the derivative of ln of 3x plus 5. So that's saying, hey, put this instantly in the denominator. And then now look at it and do its derivative, which would be 3, and put it in the numerator. And then minus, again, similar thing. It's saying, look at this, put it instantly in the denominator. So 2x squared minus e to the negative 2x. And then do this derivative and put it in the numerator. So the derivative would be 4x. And then minus, remember the derivative of an exponential function is itself. So e to the negative 2x times the derivative of its power, which would be negative 2. Okay, looks good. And then after that, we would just look to simplify or rewrite. So we've got g prime of x is 4. Okay, so g prime of x is 4. And then 3 over 3x plus 5 minus, okay, so it looks like, let me highlight this negative 2 and that negative, we should change to be plus. Okay, so big fraction bar, still 4x, but then plus 2 e to the negative 2x, all over 2x squared minus e to the negative 2x, like that. Okay, and then this again, maybe they want you to get a common denominator, but I don't think so. It's pretty nasty already. I think that would be easier to just use right there. Okay, so that's introducing the algebra rules that can help us. Again, it could have helped us on number 1, useless on number 2, but helpful with number 3 and number 4. Okay, so always try to keep those in the back of your mind for natural log derivatives. But still, the main thing with natural logs, if you have to take the derivative, throw that argument down in the denominator, and then instantly do its derivative and write it up in the numerator every time. Okay, so that's that. Thank you for watching, and if you have any questions, please let me know.